Hello friends, welcome to my channel. So today we will be trying to look into a new series that is all the lab programs related to 18MCA 30A, that is analysis and design of algorithm lab, or it's also called as algorithm lab. So now if you look into the course learning objectives, what you are actually going to learn from this particular course, that is from this lab. So already in theory now we have discussed a lot of things. So at the end of this now you will be able to understand the concept of time complexity, because in theory part we dealt with what is time complexity, and we know that how we are going to calculate the time complexity, right, for a non-recursive algorithm and for a recursive algorithm. How actually to be practically how we are going to do all those things. So those things now you will be trying to learn, and the designing techniques. So we have studied so many techniques like say brute force techniques, divide and conquer, decrease and conquer, etc. So all those techniques now we try to take the problems which we have solved manually in our theory classes. Now we try to take few examples which is given, and we try to solve it practically. So you will try to understand. So the major course learning objective here is that now practically you will try to look into implement those problems. So you try to implement those algorithms and check how to calculate the time complexity of all the few very important problems under the domains we are going to see. So the course outcome is that now you are going to implement the time complexity and space complexity of very few algorithms. So we will try to take few algorithms, we try to look into the time complexity, or how we are going to work with the time. Basically we give more stress on time complexity. So we have discussed that in theory why we ignore the space complexity, because we think for us right now the space is very cheaper for us, so we give more concentration on the time complexity. Now we will try to the outcome is that you will try to see how to implement how to calculate the time complexity by using it practically when you are implementing the methods. So the another course outcome is that now you are going to work with all the methodologies of analyzing the algorithms, like say divide and conquer, and a divide and conquer technique, how actually we use that particular technique, how we use the brute force technique. We have done the analysis of various algorithms, so those algorithms we will try to implement. Now when you come to this lab program, so I think there are around 14 programs. One by one we will be in detail, we will be trying to look into all those algorithms as well as the analysis. Majority of the analysis part we have dealt it in our theory classes. So now the prerequisite for this particular lab session is that you can try to implement these programs in a normal Turbo C environment, but basically we are using the code blocks which you have already seen in our previous classes, how this particular environment or the open-end software code blocks is going to work. So it is a very good platform wherein which we try to implement all these lab programs. So if you don't have code blocks, again as I told, code blocks is an open source. You can download it from the Google, and based on your whether you are using 64-bit systems or 32-bit, now based on that you try to install the code blocks in your system. If you are unable to do it, now you can work this program in any Turbo C environment in the Windows. Now if you have Linux or Ubuntu, then it is very easy because by default C is there, GCC compilers you can use, and directly you can work with all this program. But there is slight difference between when we go to the Windows environment when you are using the Turbo C or the code blocks, and when you are using the GCC compilers in Linux. Little bit of difference, but I don't think that that might be so difficult for you to implement and learn those concepts. So we will start with the first the program. So the first program, now what does this particular the first program says? So implement a recursive binary search and linear search. Now there are two parts here. So one is the linear search, the other one is binary search, and it is given that we have to implement it in a recursive manner, right? In a recursive manner we are supposed to implement these two problems. one is the linear search, the other one is the binary search, and determine the time complexity required for searching an element. So if you want to search an element using linear search, how much time it is going to take, and if you are going to search it by a binary search, how much time it is going to take. So then you are supposed to plot a graph of time versus n. So that is, you have to note down all the outputs. You have to note down that how much time complexity you are going to get for different values of n. Now what is n here? N is the number of elements in your array, right? So you test your program for different values of n. Say for example, you give input as 50. So 50 numbers, out of 50 numbers in an array, how you are going to search one element? If you are going to search, if you get a result, what is the time, right? Now you give an input of 100 numbers, or let us say 500 numbers, or 1000 numbers, 2000 numbers. So like this, different values of n. So that comes in your x-axis, and on the y-axis time complexity. So finally you are supposed to plot the graph. So this is what the first program today now we are going to see. So now let us open the code block, right? You know that already I have installed. So you have installed your code blocks in your machine. So, and you know that how we are working. Already we have seen the programs, or we have seen how to execute these programs in our code block environment. So now this is the code block. Let us load that once it is loaded. So now as soon as you open the code block, now you are going to get this particular screen, right? So now you get a screen, so wherein which you can create a new project. So you can see here, so you can create a new project or open an existing project. That means already the project you are having. So now let us start with creating. Directly you can click on here, create a new project, or go to the file option. Now under file, new, so you have got empty file class project. So you go to, you select the project. So file, new project, or directly from here also you can go for new project, or you can use this method. Now click on project. So once you click on the project, so now the code block, the IDE starts building that particular project. Now you will see what template you need. So this building in code blocks, you have different templates are available, right? Now for doing, since we are trying to implement all these algorithms using C language, and when you are working on a C, so we know that we are dealing with the console applications, right? So the console application, now you select the console application. So on your new form template, now you just go and search for console application. So click on that particular console application, right? So double click on the console application. So once you click on the console applications, so now it will ask for the project name, right? So click on project. Right click, so now once you click on the console application, now you are going to see the console window, right? So click on next. Now you can see C and C++. That is which language you are going to select. Now click on C language, because we are going to implement it in C. Then click on next, right? Now here you have three options basically. Now you are going to fill. The first one is called as a project title. So you have to give a title to your particular project, right? Let us give program 1 as our title. So in the next column here you can see now the folder, now where we want to store your folder. Now here by default it is saying the desktop. Now let me store it. Otherwise you select your particular folder name, now where your project has to be there. So you select it from here, the project, that is the path of your project, enter the project title, click on next. So once you click on the next, now you go to the another console application window. Now don't do any changes here, right? So all the by default the settings have been taken by the code blocks. Then click on finish. So if you are already having a file, so then it will ask for override that file. Now otherwise, now it complete. Now program 1 project is been created. So now the code blocks, now it tries to get all the required libraries or all the functions or the background, the DLL files, what is required for executing a particular file, that means or executing the program in C. So once it creates the entire template for us, now you can see the management window. So now the left side you can see here management window. Now here under the projects you have sources, right? So this is the name what we have given for this program 1. Now under the sources, now if you click here, now you can see main.c. Now this is our file. Now double click on this main.c. So now you can see our main program, or by default one program the code block is going to give us. So let us wait, since it's taking bit time. So now by default, now any project you are going to create or any programs you are going to start in your code blocks, now you can see one particular program. Now you can see here, now by default it has created a program. Now what is that particular program? Now it is saying now include stdio.h, include stdlib.h. Now these are the two header files now which are been by default you are going to get. So you need not type every time when you start your program the include stdio.h and include stdcode.h. So by default these two header files are there. So then you have got int main and a simple statement print hello world and return 0. So right, so now once you get this particular template, now you can go and execute this particular program. So why we want to execute? Just to check that all the class path and everything is been set properly or not. Now you can try to execute this program and check that are we going to get the. So we want to execute and check whether everything, this class path and all is set for this particular program. So now you know how to run it. Now here you have got the run and you have got build and run. Build and run means compile and run your program. So we'll go for directly build and run. It compiles your program and gives the output. Now click on this particular build and run and see that is the program executing. So that means are you going to get the output? Now if you get the output, so it is clear that yes, the class path as everything is set and your code block is working properly in your machine, right? So now let us see that now what is the output we are going to get at the end of this particular program. So we have clicked on the build and run the program. Now once you are building and running the program, now or we can say when we are doing certain programs, you know that we are going to get some errors. Now how to see these errors? Where does the notification of this error comes? Now to do that you have to go to the view. Now you have to click on view and you can see the log reports. That means when you click on view, now you can see logs, or you can press F2. Now if you press F2 downside, now you can see a logs. That means if you have done any errors in your program, so now all those errors are being available here. So which line number, what errors you are doing. It might be very simple typing errors which you are trying to do it. Now all these things have been indicated in our log. So Now we got the output. So for this particular simple program, so now you can see here what was our program here. This was the default program. We have not typed anything. So what was our default program? So printf hello world. So now you got hello world as your output, right? So press any key to continue. So now this is how we are starting the code blocks, and as soon as you open your program, now you get by default. So now as I was telling in the class that if you want to become a very good programmer, try to build as many as functions, right? The functions are very important for us. So we need not worry about our main program. See, generally you try to by heart. So at the end of this particular lab sessions or in the algorithms lab, the programs will be very big that it is very difficult for us to by heart line by line, because if you are going to by heart, you start by hearting from hash include stdio.h. So you need not by heart. Think the algorithm and think our problem, now how the problem has to be implemented, converted, because we already know how the syntax of a C programs or the structure of a C programming language. Just thing is that we have to know our algorithms or the problem. So we will start with the first problem. What is that first? That is first program. So we will give a comment section. So now you are supposed to implement linear search and binary search, right? So now here, now we try to add some of the, apart from the stdio.h and stdlib.h, now include. Now as soon as I type 4 characters, so why the code blocks is very important. Now you see, as soon as I type hash inc, so a pop-up menu comes which gives us the required reserved words. So you need not type completely hash include. Now you can see, as you type 4 characters hash inc, you got here down, you can see here already include comes. So whichever you want, just if this include, because we want to type hash include, once it comes just press enter key. So now the reserved word is available for us. So hash include, now we will use one header file called as windows.h. Now this is required because we have to calculate the time complexity, right? Now we need, so another header file hash include windows.h. Now we'll include another header file called as time.h. Now these are the 2 header files we are going to include. Now as I told that you need not worry about main. So the main program, we are just accepting the input from the keyboard. So right now forget about the main. Now we have 2 problem in front of us. What is that? First is linear search, binary search. So first we will talk about the linear search. So now linear search. Now you are going to search an element linearly. So generally in theory part, when we have discussed now how we started, so you have taken an array. Now you take the element which you want to search. So now you take that key, the searching element. Suppose say that if this is an array which consists of 5 elements in your array, now you want to search a key element, so you start with the first a of 0. So you check whether this a of 0 it is equal, or go to the next one or next. So like this you keep on scanning each element in an array. So now you have to do it in recursion fashion. Now we are going to implement a linear search in a recursion. So now what we do in a linear search in recursion, instead of searching from the starting, we will search from the end, because nowhere they have mentioned that you have to search from the beginning itself. Now we will search it from the end, and you have to give, if the element is found, you have to return at which particular position the element is there. So we'll start our function by saying int. The return type of this function is int. It gives us the position. It gives us the position at which the element is found. So now we'll define the name of this function as linear search. So now we have to give the arguments. Now what all the arguments is required for us? So int a, that is array. So we need an array. We have to accept the array of elements, right? Now whenever you are implementing the programs in C, whenever you are implementing it as a functions, you have to passing the parameters. As soon as you write or as soon as you define array, immediately next is size of the array. Right? If you are having A as your array, now how many elements you need? What is the size? So we'll define int n. So n is the size of the array. So don't by heart the programs. You know that you need an array, you have to pass an array. This function ls, linear search, it searches the key, right? It is going to search an element in a linear fashion, in a recursive manner. So to do this function, what I need one array, right? So it is of type integer, so I have declared int a of array a. Then what is actually size, how many numbers are there in this array? I will declare it as int n. Next, which element I want to search. I should know that also. The function should also know that what is that element you want to search. So now we are going to search an element which is of type int, and we are going to write it as key, right? The key is the element which you want to search. So now these are the three arguments what we are going to give or pass to this particular function, linear search. Now so next, now we'll start building this particular function. Now for the first line, since you are doing it in recursion, so now you have to remember that all the recursive programs are divided into two parts. The first part is called as termination condition. If you look into any recursive program, the first line immediately after this particular you can see here the prototype or the header of this function, immediately next should be the termination condition, or what we call it as the base case. So so from where the program has to stop, then the body of our recursive program start. Now what is our base case here, which is the termination condition? So the termination condition is if n is less than 0, right? So the n is what? N is the size of the numbers or the elements in our array. So as soon as if n is less than 0 means you don't have any elements, right? So if n is less than 0, so now we will return -1. So -1 indicates the element is not found. Now else if now you are going to start our processing of linear search. Now you will take our key element. What you are supposed to do? Searching, right? The problem is searching. So what you are going to search? The key. So you are supposed to search your key. So else if key, if it is equal to a of, right, in array, a of n minus 1. So why we are giving here n minus 1 is that we are starting from the last element, right? So first you check. Instead of starting from first, I am starting from the last. It doesn't mind for me because actually I need the output. So I start from the last if key is equal to a of n minus 1, the last element in our array. So array is of what? Size n. So you have n elements in an array. So as you know that if you have n elements in our memory, so you are going to store from 0 to n minus 1. Right? So if in the array is of size n, so in the processing in our memory, in the computers, now the array processing starts from 0th position. If you have total 5 elements in your array, that is if n is equal to 5, the processing happens from a of 0, a of 0, a of 1, a of 2, a of 3, a of 4. 4 is n minus 1. Right? 5 minus 1 is 4. So we will start from the last element, which is this last element, so which is present in a of n minus 1. So here we can see, like, we are going to type if key is equal to a of n minus 1. So that means you have found the element. Now if you have found the element, you just return the position. What is its position of that element? It is n minus 1. Right? So if the last element, if it is equal to the key, you return n minus 1. Else if suppose if the last element is not our key element, then you have to go to one element back. You have to go to back because you have started processing from the last. So if this is not the key, then you have to go back. Now going back means you have to go back and again search key is equal to n minus 1. Instead of doing the same thing, we will call recursively. Instead of that, I will just say return, you call your function linear search, right? I'm going to call the linear search. Now you can see the advantage of code using code block. Now as soon as you type this function linear search, so down you can see a pop-up menu. Now this pop-up menu or this particular information indicates that for your function linear search, what are the 3 arguments has to be given, and the series, the manner in which it has to be given, because if you mismatch here, you won't get the output. So now the blue color indicates that the first the subscript what you are supposed to give, that is the first argument what you have to give to your function linear search is an array. So I will type a comma, the second argument, again it has become blue color, so it is the size. Now what is your size of your array? Now you see that the last element you have checked, and if this is not equal, now the size is reduced by 1, right? Because you are going back one by one, you are going back, the size has been reduced, right? So now what will be your size? Instead of n, it will be n minus 1. And key, which element you want to find? You want to find the element key. Just type key and end it with a semicolon. This is in linear first, in linear recursive manner. Again you call the linear search with a as your array, n minus 1 as your the size of your array, right? And the searching key. That's all. Our linear search program is completed. So now how many lines are there? Now if you look, just 3 lines are there. Just I try to understand the particular problem. So the first is our, in recursion we are going to do our linear search. The first line is that if n is less than 0, return minus 1. That is our base case when we want to stop our program. Else, if key is equal to the last element, that is a of n minus 1, return its position. Else return, call the linear search a comma n minus 1 comma key. So now 50% of our program is completed. You need not by heart. So simple. Just 3 lines for our linear search, right? So now we'll go to our second task, binary search program. So again it also has to return at which position it is the element is found. So return type will be int. Now we will give the name of the function binary search. Now what all the things is required? So we need an array. As we know that you need an array. Now just like I told, as soon as if you are going to declare an array, you need the size, that is element present in that array. But now if you look into the concept of binary search, we have studied that you are using divide and conquer. Now under the concept of divide and conquer technique, the problem which we have studied in theory is binary search. One of the problem, right? We have discussed so many problems on binary divide and conquer, but one problem was our binary search. Now what does the binary search says? Using divide and conquer, you have to divide your array into 2 parts, equally 2 parts. Now if you want to divide your array into 2 parts, now how do you do it into 2 parts? So you need the first element, that is, and you need the last element. So the first element of our array, you can call it as low, and the last element of your array, you can call it as high. And you are going to calculate the mid position, right? Starting or end, mid, whatever variables you want based on your convenience, you can use it. Now we need 2 pointer positions of your array. The first position, let us take low, right? So low is our first position. Next, high is our end, the last position. So low is the first position, high is the last position. So we know what is the first position, we know what is the last position. We have to calculate the mid. That is what the binary search says, calculate the mid position. Now apart from this low and high, now we need the searching element, right? So you have to search this element key. You have to search this element key. Now what we told, this is a binary search, so we need to, let me close this log here. Okay, so now we need to find the mid position. So we need one variable, so we will declare in a variable called as mid, right? So mid is a variable we are going to have. Now the first, we start with the base case, the termination. Now what will be our termination condition here is that now you are going to check if low is less than or equal to, if low is greater than high. Now you know that when you are going to process this array, always the low pointer should be less than the high pointer. Low is the starting position of your array, high is the last position of your array in the elements, or you can say the first element as well as the last element. And you know that the first element, the position of the first element should be always less only. By chance if it is greater than, if low is greater than high, so then we just say return minus 1. We return minus 1. Now else, so this is the termination condition, right? Or we can say that, I think, so first we will calculate the mid position, right? You have declared int as mid, so we will calculate the mid. So we will divide our array into equal half. How do you divide? So low plus high. So you are going to calculate low plus high divided by 2, right? So now you have divided your array into exactly half mid position. Now you check if low is greater than high. If low is greater than high, return -1. Now else if, we will give another condition. Now you start our searching. Now how do you search in your binary search? Now you have studied that you take your array, you are going to divide your array into exactly half. So once you divide it into half, once you are going to divide your array into half, so you get the mid position. Now you are going to check your key is less than the mid or greater than mid, whether it lies in the left part or whether it lies in the right part of your mid. If it is in the left part, ignore the right part, just take left part as your array and again apply the binary search, that is divide and conquer, again divide it into half. So the same recursive manner it starts. Now you want to check that, right? So now what we do is else if, now you check if key is equal to a of mid. Now is this key equal to a of mid? So since you have found the mid position here, now is it the element present a of mid? Mid is just a position, it is just a pointer, right? It is just a position. When you put that inside your array a, it gives the element. Now you are going to check a of mid, that means element present in that particular middle position of our array, is it equal to key? Have you found the element? If it is equal to key, then you return that position mid, and you are going to return that position mid because you have found the element. Else now two possibilities going to happen. Now it should be, the key should be less than the a of mid or it should be greater than the a of mid. If it is less than, your array will be from starting position 0 to mid -1. If it is greater than, it will be right side. Right side means was mid +1 to last or high, right? So now we are going to give that position. So what is that you are going to see? Now if key is less than a of mid, if key is less than a of mid, so now what you are going to say, return, you have to again do divide and conquer. So return. So you are going to call the binary search in a recursive fashion, right? That is, say divide and conquer you are going to. So left side means what? So it is in the left part. Now you will pass the array a in your binary search. So next low. So left part means, so low will be the same value you will be having high. Now what is your high value? Because this is the function, low, high and key you have to provide. Now what will be a high? Now your high value will be till mid -1 because you are divided into mid. So it will be mid -1, and what you want to search? You want to search an element key, right? Now if it is less than, else it will be right side. So we will say else return binary search, right side you are going to call. So a is your array. Now you have to adjust your pointers. Now what will be your pointers? It will be from mid +1. It will be from mid +1 to high. So we'll say now your low will be this second argument which was low. Now it will be what? Mid +1. So mid +1 to high. Mid +1, comma high, comma key. Right? Now this is your binary search. That's all. So these are the two functions which you are going to implement. One is linear search and the other one is binary search, right? So now this is the one program. Now we have to design a menu driven program and try to call these function linear search or binary search now how we require. So now we will start to go to our main program. Our entire program has been completed. So now we will go to the main. Right, I have not typed anything. So this main was by default, it came when we started the code blocks. Now these things is not required, so we will delete this particular first line. Right, now we are going to look into our main program. So we need a menu driven program. Now let's say 1 linear search, 2 binary search, 3 exit from our program. So we will start declaring all the variables. Now what all variables is required for our entire program? So you know that we need an array. We will declare an array of size, right? We need a larger array, because you see that now in our theory class, in the first chapter we have seen order of growth. Now if you want to look into the time complexity, order of growth is very, very important for us. What do you mean by order of growth? The time complexity or the changes what is happening in our program as n increases, or we can say that behavior of our program as our input n increases, what is termed as order of growth. Now if you want to check the linear search, the time complexity of linear search or the binary search, if you just give 5 elements and try to find the time complexity, how much time this system is going to take to search an element in given 5 element, it will be negligibly small, it will be very, very small. That means the system is very fast, right? So we are not interested as n. If you look into the definition of asymptotic notation, so whether it is big O notation or omega notation or the theta notation, as n or after n greater than n naught, we are going to find the time complexity. So we need huge amount of elements in our array, not 5 elements or 10 elements. So here we will take an array A of, let us say, 10,000 element. Now every time the linear search and binary search, it returns the position. So we'll take, to store that, we'll take a variable called as position. Now you are going to search an element. What is the key? You know that you want to accept elements in an array. Processing a single dimensional array, we will take a counter variable I. Now choice. Now we are going to use it, menu driven program. So when you are using a menu driven program in C, we need switch case. For switch case, we need a variable called as the choice. Make a choice based on switch, or switch your control based on choice ch. Now what is the size of your array? Now you are going to take it as n, right? And choice. Now what is your choice? Whether it is linear search, whether it is binary search, or you want to exit. So we will take another variable choice, and by default we will initialize this choice to 1. Now these are the general variables which is required for our program. Now as we know that we are going to calculate the time complexity, right? So now for finding the time complexity, we need some other variables here. So now here we are going to take one variable called as the clock variable, or let us call it as C. Now this clock variable should be of type clock underscore t. Now as soon as you type here clock, now you can see here, now you are having one built-in function clock. You will get another preserver clocks per second. Your third one is clock underscore t. Now click on this clock underscore t, right? This is the type definition. So this is the clock underscore t. So now we are going to take one variable, clock variable C, which is of type clock underscore t, right? We will see when we are how we are using this C in our program, right? Now these are the variables which is required. So now we will start our program. So first we will say printf. Now what is required? We want a menu driven program, right? We want a menu driven program. So first we will say printf /n, that is to come the print it in the next line. Every time we want to print it in a new line in our output screen, so we use /n. So enter number of elements, so that means how many elements you want to consider, right? Now how many elements? So 5 elements, 10 elements, 20 elements. As I told that we should use larger, n should be more, then only you can find the time complexity, right? We need n. So let us say that always n should be greater than 500. We should input more than 500 numbers. So how many elements you want to take? So printf enter the number of elements. So now we'll use scanf. So you know %d comma ampersand n. So these two lines are used to accept the number of elements, how many element array you want, right? So now we'll use the while loop. So we want to a manual driven program which gives us 1 linear search, 2 binary search, 3 exit. So we use a while loop. Now while, now what is our choice? Now while choice is less than 3. So we have 3 choices, right? So 1 is linear search, 2 is binary search, 3 is exit. So then obviously now while this choice is less than or equal to 3, we keep on continuing this program. So we want it in a menu driven program. So we'll use our while loop here, right? So now what we are going to display the menu. So what we want in our menu. So printf, right, double quotation /n. So what is the first type of program we need? Linear search. Linear search /t. Small t. Small t means tab character, right? It comes in the next, or you can use /n to print that in the next lines. Now /n. So second is our binary search /n, and the third one is exit from our program. Exit from the program. So this is how it comes in our display or in the output. So now 1, 2 or 3. Now it asks us, right? So the program has to ask us whether you want to go to linear search first, or whether you want to perform binary search first, or you want to exit from your program. So you need to give the choice. So I have to accept it. So we will use scanf %t, right? Now which is your choice? Now I have to switch. I have to use switch system, switch case based on this selection, whether it should be linear search, binary search or exit. So we will use a variable ch for that. So scanf that particular variable ch. Now we will use the switch case. Now you are going to switch based on your choice. Now what is your particular choices? So whether it is linear search or binary search, like that, right? Now switch on our choice. So now we are going to start with our cases. What is our first case? Here what we are given, linear search. Now we are going to look into our linear search. Now if you look here, till now what we have accepted how many elements should be there in our array, right? Now here you are giving like say 500 elements or 1000 elements, 1500 elements. Now out of 1500 elements, now you want to search a particular element, right? That means till now you should know what elements. You are given just n, but what are the elements? Now so we are going to accept those elements from the keyboard. So printf, right, /n. The elements are. So I am writing the elements are. So now you can see here. Now as we told, now you want to accept the element from your keyboard. Now is it possible for us to accept 1000 numbers from the keyboard? Because as I told, n greater than n naught. For smaller values of, if you are going to search an element in out of a 50 numbers, or like say 5 numbers, give an array of 5 numbers and try to search an element in 5 numbers, means the system is going to take very fastly it searches. For the system it does not take much time. The time will be 0, 0, 0, almost 0. When the time is 0, how do you calculate the time complexity? If you want to check the performance of our system, only we can check the performance of our system when you give more number of input. As n increases, that's what the order of growth definition says. So now when you want to accept more number from our keyboard, so now it is very difficult for us. I cannot type, or you cannot type 5000 numbers from the keyboard one by one, right, randomly. So what I want, we will take this randomly. So randomly the system will generate some 1000 numbers and it stores in our array. So for that, so now we can use for loop. So for I is equal to 0, so array processing, I have to store the random numbers in my array, right? So now for I is equal to 0, I is less than n. sir, totally n numbers. So here how many elements you want? You want, let us say, 1000 numbers. So for from 0 to n, I less than n, I plus plus. So now what you want? Now you want randomly, you want to generate. So you want to generate randomly, correct? Now you want to generate randomly. Now how you are going to generate randomly? You are going to use a built-in function random. So we will say now a of I in your array a of I. So I am going to store randomly. Now there is a built-in function called as rand. Now this function, it generates some random numbers systemly. The system is going to generate. If you say n as 1000, now the function will generate 1000 numbers, right? Because we are putting this inside this for loop. I is equal to 1, it generates one random number, store that in the array. I is incremented, then I becomes 1, so another random number it generates and it stores, right? Now it stores the random numbers. So now here the random it generates. Now basically random numbers are generated between 0 to 1. 0 point, that is 0 to 1 means it will be 0.1. So if you want to have certain fixed numbers, like say I want to only generate the numbers between 0 to 100, that means 2-digit numbers, or 0 to 1000, that means 3-digit number, that means 000 to 999. So for doing that, now we are going to divide or use the modulus operator. So you are going to get the integer division, divide it by 100. Now if you divide it by 100, this random function, whatever the numbers you are going to get, now you will get all the numbers, 2-digit numbers from 00 to 99. So now you have got the number. Now all the random numbers are stored in our array. Now you want to search which number you want to search, but I don't know which are the numbers are stored in the array because it is generated randomly. So I will display it on our screen by using a simple printf statement to come to know that which are those numbers it has generated. So printf %d /t, right? So I'll give some space after each number. So %2d /t a of I. Now we will display all the numbers which are been randomly generated, so that I will come to know that which number I want to search, which is that particular number I want to search in our particular program. So then only I can give the number to be searched, right? Now this for loop, gives us so how we are searching, right? So next, which number I want to search? So printf so now what, /n, enter the search key. Now you are going to enter your search key, which number you want to search. So we'll use scanf. We have taken a variable for that, %d, right, ampersand key. Now you take this key, that is which element you want to search. So now all the things are being done for us, right? For linear search, you have an array of n numbers, randomly it is generated and it is stored in our array. Which number you want to search, that also you got, right? That is the key. Now you have to start the process. You want to search linear search. Already the function has been written, so already the function is ready. Now all the required input we have taken. Now you have to pass this to our function, right? Now before you are going to pass all this to our function, we need to calculate the time complexity. As we have told in our theory classes that you need not worry, we are ignoring these statements because how much time it takes to randomly generate, all those things are not required for calculating time complexity, right? Now if you look into the time complexity definition you have studied, now what is required for us? The basic operation. What is that basic operation? Now these are we can say this is the actual part. So now before you call this function, I will start the system clock. In our system there is a clock which has been running. Now we will start that particular clock. Now how do you start? Now clock variable we have taken C. So we will see that we'll take this variable C. Now I will use a built-in function called as clock. Now this is the built-in function clock. Now what happens? Right now you are starting your system time because you want to calculate how much time it takes to search the key in our given array, right? So how much time it takes to search this key in this particular array. So you start your clock. Now the clock starts. Now you call your function. So what is that function? Linear search. It returns a position. So we'll say position. I have to store in which position you have searched the element. Now we will declare our function linear search. So linear search. Now what is the first argument you have to pass to this linear search? Array A. The second argument it says the size, that is n, and the third argument is key. So you have accepted key here, right? So you pass that which element you want to search into your program, right? So now all this data goes to our function linear search. It goes to this particular function linear search. It searches for that element and it returns the position. Whatever, if the element is found, it returns the position, otherwise it returns -1. Now it is stored in this position. Once you got the result, I have to stop the clock, right? Now you can take another variable also, start and stop, or else what we can do, already when you have started your clock, it is stored in this particular variable C, right? So now again I will take C equal to C minus clock. Now again here we can call it as a start, just to avoid number of lines that we have written. Otherwise you can take two variables, start and stop. At that time here you take start equal to clock, then stop equal to clock. Then if you want to find the difference, right? Starting time, ending time, find the difference. It gives you the time complexity, right? So instead of two variables, we have just taken one variable. So we'll take the same variable C, whatever value it was stored previously. This was the starting value minus, again you call the clock, that is the stopping value. The difference is stored in this C, right? So next, so once you have started the clock, you have stopped the clock, your task is completed. Now if element is first searched and the result is stored in position, right? Now we will display that. Now we will check that position value. Now if your position is less than what? 0. If it is less than 0 means, so element is not found. So we'll just say printf /n, right? So you are going to check if the position is less than 0, printf /n element not found. So element is not found in your array. Now else you are going to say that element is found, right? So now in which position the element is found, that also is very important for us. So now else, now we'll say printf /n, so element found at position equal to %d. Now which is that position? So it is POS. So it is returning us. So this function returns this particular position, right? POS. Now you know that the array processing starts with 0. When you are counting in our system, starts with 0, but we count from 1, right? So we will add 1 to this. So position plus 1, right? So now the position also is displayed. Now the last thing what we want to display the time complexity. So we'll say printf. So now printf /n. So the time taken to search is equal to %e. So now why we are using E is, so the time taken is very small here. So it is displayed in e to the power of scientific notation. So for that, the data type we are going to take it here is E. So percentage E, comma. Now how do we calculate? Now since we have already started the clock and we have stopped the clock, and the difference time amount, the difference of our clock we have mentioned, right? So we have mentioned the difference of our time amount. So now this particular difference, right, now we are going to divide it. So what is this difference? Now this difference is stored in this variable C. Now C divided by clocks per second. So if you type in capital letter, now you can see here clocks per second. Now this is another macro definition built-in function we are having. Now this clocks per second. Now why we are using this clocks per second is that now how many clock pulses are generated? How many clock pulses are generated from our system? You have to divide it by that so that you will get the how much time. So the difference amount of time divided by clocks per second, it gives us the time complexity. So we print that time complexity. Now our entire task is completed in case 1. So you use break. So because you know that in switch statement case 1 you have to use the break. Now this is our linear search is completed. So now we will go for our second case. So which is our second case? Now binary search, right? Second case is our binary search. Now the binary search is there already, the function is there. Now we have to type. Now you see that in binary search also the process is same, right? You are going to do the same process, you are going to do it. So you are not trying to do something else. The process is same in linear or binary search, because you have to accept an element, you have to accept a searching element, right, and do the thing. Only thing is the technique is changed, methodologies have been changed. So what we do is that now I just copy this entire thing what is present here. We'll just copy Control C and I will paste it after case 2. Right, now we'll see what all the different changes we want to do it. Now we are going, case 2 is binary search. Enter the elements, right? Now we are going to accept the elements. Now in binary search there is one important condition, that your array should be in sorted order. Array should be in sorted order if you want to apply the binary search. Now if you take here a of I equal to random, if you generate random numbers, then you cannot implement binary search. So, right, so now here this is ruled out. So what we are supposed to do is we need the arrays in a ascending order. So instead of the best method what we can use here is that you are putting that in a for loop. So you are starting for loop from I is equal to 0, I is less than n. In an ascending order it keeps on incrementing, right? I plus plus, I is equal to I plus 1 each time. I starts with 0, then 1, 2, 3, etc. up to n. So how these are generated, in the same manner we will put this in our variable I, or in our array I. So a of I equal to I. That means in the same order how the processing happens, that same thing index value you put in your as an element of your array. So now your array consists of all the elements in ascending order. Suppose if you give here the n, right? Here you have given n value, right? Now if you have given n as 5000, so it starts with 0, 1, 2, 3, etc. till 5000 in ascending order. So that solution, that condition we have met. That means elements are in ascending order. So we can go ahead with our binary search, right? Okay. So next, which is the element you want to search? The same thing. Start the clock. Now you are going to call the function. Now here what function you are going to call? Now we will delete this. Now we want to call binary search. So binary search. Now what is the first argument you have to give? The first argument is A, right? So the first argument in our binary search is A. So then starting value. So what is our starting position of our array? Starting position of our array is 0th position, right? 0th position. The last element, last position of our array is n, low, high, and which is the key element you want to search. you call the function binary search. Now it returns the position. Next, all the other things are same. All the other things are same. So now our binary search is completed. So now we'll go to the case 3. What is our third case? Now you want to exit the program. So we'll use printf /n. Now do you want to continue? So do you want to continue your program or not? So you'll accept that value. If you give 1 again, it goes to linear search. If you give 2, it goes to linear binary search. If you give 3, you have to exit from your program. Right? Now enter your choice. So scanf %d, comma, ampersand choice. Right? So now what is the choice here we are given? So choice is less than or equal to 3 we have given. Right. So now here, now we can make one thing. Since you have these 1, 2 and 3, these are all the selections for our linear binary search. Now whether you want, see, as soon as here if you type 3, you will come to this case 3. Now again here you say, do you want to continue? If you give 1 here, you will go to this loop. If you give 0, you are going to come outside of our loop, right? So since you can take 1 and 0, now you can just type here choice, while choice. By default choice is 1. Now here if you want to continue, so either 1 or 0 you have to type. If 1 means you will continue, 0 means you will come outside this particular program. So now this is the end of your case 3 break. So now if this is your end of your switch statement, right, and this is your end of your while statement, and this is your end of your main. This is the end of your main. So this completes the complete program of the first program, that is linear search and binary search. So it is very simple. Try to understand the concept. Now if you start by hearting this program, you have to start by hearting from line 1, and you see that slowly part by part we have built this particular program. Okay, now let us try to compile this program, and we will check whether this program is going to execute properly or if there is any errors. Now we'll try to see. So just click on build and run, and whatever the errors, so that the logical errors, once you will come to know when the output when you are going to get. If there are any syntactical error, so it displays the error. Now in which particular line, now what error you have done. Okay, so I think it is taking so much time for us to compile this particular program in this particular system. Now anyhow, now the when you are looked into this particular first program, as I said, linear search and binary search. So binary search, we are using divide and conquer. How you are going to divide, right? So if you look here, find the mid position, right? So once you have found the mid position, check whether the key is less than mid or key is greater than mid. So we'll see, we'll open our log, that is F2, and we'll check. Still the program is executing, so it is taking bit amount of time in order to see, in order to compile the program. Now anyhow, if the key is less than the mid, it lies in the left part. If it is right side, it lies in the right part of our array. Right? So it is executing. Let us see. Now have you got any errors? So if the errors are there, now it will display in our log in which particular line the error is there. So there is here. Now you can see here, now the program has stopped at this particular line 31. What is this particular error? The name what you have selected here, so what we have typed. Now while choice, now if you go to this particular line 31 here, now you read, first read what the error. Now it is showing error choice undeclared. Now, undeclared means what? When you have declared the variable here, what name you have given, you can see it. Check the name, CHOICE. And what we have used here, CHO. So there is the spelling mistake, right? So you just correct it, ICE. Right? So again, you compile your program once again and see if there is any other error. It's good, but if you get the error, once you get the error, then only you'll come to know how to debug that particular error or what mistakes you have done properly. Okay. So we'll see now it is compiling. So after building your linear search module and binary search module, so you start with the main program, and we are using the clocks per underscore t now to find the time complexity. Now there are 4 programs in our lab exercises wherein which the method is the same. Now you are going to start the clock before you call that particular function. You start the clock. Once the function ends, you stop your clock, right? You stop that particular clock and find the difference. Now whatever the difference you are going to get, now before you have stopped your clock and you have ended your particular clock, find the difference, and it should be divided with clocks per second. So the clocks per second will give you the time complexity, so that once you get the time complexity, you just print the particular time complexity. Now let us see again, is it going to give us any syntax error? Check the program once again. This is another advantage of using code blocks, that is these brackets and all. So it is very clearly will come to know that whether you have missed any bracket or not, and the alignment also, it will be very determined form, so that it becomes easy for us to read the program also when you have typed your particular program. So okay, so when we run the program now, okay, it is stopping here, we are giving an error. So what is this error? BS. The function name what we are given for binary search is capital B small s, but here we have typed capital B and capital S. So you should be very careful with respect to the characters what you are typing, the function name, the name of the function. So instead of using these two characters what we have done here, the best way is type completely, right? Binary search, binary underscore search as the function name, so that it becomes easy for us. So here it was capital B small s. So you have to take care that everywhere, wherever you are using the function, it should be capital B and small s. Right here we have done a mistake. We have typed capital B, capital S, and we have corrected it. Now once again, you check you run your particular program. You see that, is it going to give us any errors? These are some of the very simple mistakes generally what we do in order to, when we are trying to write the programs, the names, the function names or variable names. If you try to give very small names, or capital letter, small letter, so then there you will be getting the lot of confusion. So to avoid this, try to give some meaningful, little bit larger variable name, so that you can remember it when you program, even the length of the program, increases. So it will be easy for you to remember these variable names whatever you have done in your program. So I think now the program is been it's been compiling. I don't think now you will get any errors, so that you will be getting the output of our particular program. So we will check how the output is been we are getting in our particular program. So yes, we got the output, that is execution is done. Now let us check. So enter the number of elements. Now let us initially will check it for smaller values, but you should not record this whether you are going to get or not. So now let us say that I give the 50 numbers. Okay, so the array has got 50 numbers. Two options for me: go for linear search or for binary search. Now first we'll go enter the choice as 1, so that is linear search. Right, now it is generating 50 numbers randomly. Now you can see that it is trying to generate 50 numbers. Now randomly it has generated and displayed 50 numbers. Now in this I want to search one particular number. Now let us say there is one number 0 here, right? Now I will give the key element to be searched is 0. Now it is telling that now 0 is present at this particular position, right? So 1, 2, 3, 4. So it is displaying in the 4th position, right? So let us once again run it. So it is taking much time because the system is very slow. It depends upon the system, it depends upon the execution speed. Otherwise we will try to get very fastly, we will try to get the result. That is, first we are just checking now whether the searching is happening or not, right? So whether our searching is happening properly or not. So we will give a 3-digit number. We know that in our array there is no 3-digit number is not found itself, right? Now you see here, now you have given the element 50 numbers. In this 50 numbers, all these numbers are 2-digit numbers. Now you are going to search a number 234. Now 234 is not there. Now what is the output you are getting? Element not found. Now you can see the time. You have to note down this time. So it is taking 4.96570 e raised to the power of minus 312. E raised to the power of minus 312 means 0.312 times 0, 0.0000, almost 0 it is. That means so fast it is trying to search the element just for 50 numbers. Now we'll go and check for binary search. Now the second option is binary search. Now you can see that automatically the numbers, that 50 numbers are being generated and all the numbers are in ascending order. Because you know that binary search, if you give the array should be in ascending order. Now it is in ascending order. Now we will search a particular number. So when you are searching this number, now you can see here, so you are going to get, so what is, it is present in the 16th position and the time complexity. So the time complexity here it is telling 1.060998 e raised to the power of minus 312. So this is how now we are calculating the time complexity of our particular program. So now you have to note down. So you have to give these for n is equal to 100, 200, 300, 400, 500. Note down this time complexity for linear search, binary search. Then you have to draw a graph of n versus the time complexity. So that completes the actual program. So now the third option is what? So when you press the third option, exit, now it asks, do you want to continue? If I press 1, again you go back to your program itself. If I press 0, we come outside of our particular program, right? So this is the first program. Now you just practice this program. So all the program has been already given. So okay, so if you have any doubt, so you can just drop a message in our Google Classroom. So in the next class we'll go with our next program and we'll see how we are going to implement that program. Anyhow, thanks for watching this video, right? So bye bye.